Hi guys, and welcome back to Lesson 2 on Programming for the Microbit. The aim for today's lesson is to develop block-based coding for the Microbit and to see its relevance in the real world. Again, there are three objectives for this lesson. The first is that you must understand the basics of an accelerometer. The second is that you must complete a version of the code for a spirit level. And the third is that you should understand the logic behind the blocks of code and what they do. You may pause this video now to watch the attached video on accelerometers. There are actually two to improve your understanding. Most accelerometers now measure movement in three axes. That's X, Y, and Z. That means it gives a total of 6 directions that they can measure acceleration in. And that is up, down, forwards, backwards, left, and right. In the code that you will be creating today, all motion will be sensed on the X-axis and will be measured in mg, which is milli-g. That's 1,000th of a g. 1 g is the equivalent to the gravity that we feel on Earth. It is a fact that some fast jet pilots experience up to 9 g whilst pulling off some manoeuvres in the air. That's 9 times the gravity us commoners feel on the surface, and can be enough to cause inexperienced pilots to black out. So, without further ado, let's dive in and look at the code. Firstly, you must click on the link I provided for the Microbit Editor, which will bring up this familiar page. You need to then click on New Project yet again to bring up a fresh page. I am going to click into my own program here to show you how to create the code. So, if you notice guys, I've used blue blocks, teal blocks, and the dark pink blocks. Okay, so these are the basic blocks, the logic blocks, and the input blocks. And for these blocks, what you do need to start with is the forever block. So I'm going to drag one out just to remind you how to do it. And I'm going to place it here in order to recreate part of this code. So the next thing I want to do is in that forever block I need to place an if block. And these are called logic blocks because if something happens, we want it to show something on the LED screen. So we go to the logic block, we grab our if block, and we pop that in between. Now the plus sign here means you can add more if statements for separate things happening within that same block of code. The next thing we want to do, guys, is we want to know what we're measuring here. So we're going to drag in the pink block, the other teal block, which I've already got out, which is here. Now you will find that block in here and in the comparison blocks here, and you can change these to whichever way you like. You can also drag code into these little windows. So the next one we need is the pink acceleration block. We can use degrees for the level, but that's not an issue. We've decided to use the acceleration one for this because we've been talking about the accelerometer. So we'll drag this into the first block here. Now you'll see how to create this section. What we can also do is, if you notice here, we have an AND statement in there. Well, that's all you have to do is drag this block in here, which is a Boolean response, a yes or no response basically. But then what you can do is you can drag those smaller blocks in and create the code that way. And if you're stuck, just look at the colors of the blocks, look at the shapes of the blocks, and drag one out and just see what is under these drop down menus. Okay, that's a good way of looking and making sure you've got the right blocks in. So now what we need to do, what you can start with, is the easiest place to start on this program, is what happens when the spirit level is level. So we know what we want to display. Now you can do this one of either two ways. These 25 squares here represent the 25 LEDs on the front of the microbit here. So you can see that when I have the spirit level level, I have this shape. Now this extra block of code is actually going to mess with my code over here because I've got another bit of code running. Okay, you can do this the other way though. If you wanted level, which makes more sense, you can have a straight line which says it's level. Okay, it's just I wanted mine to look animated. So after that, after you're happy with that, we need this to equal between two values. As you can see, we've already got the wrong one up here, so we'd have to switch one out if we were starting from that point. So we'd go to our logic, we'd get our AND box and we'd pop it in, and we'd get one of these and pop it in there, and then we'd copy this block and we'd pop it in there. Oh, sorry, wrong one. Duplicate that and pop it in there. Let's just delete those and tidy up. So as you can see guys, we have between one value and another value, we'll show this. Now we know that 0 is dead level. So what I've done on mine is that I am going to switch it from between minus 50 and 50. So we're just making sure that we've got the x-axis in both these boxes because that's the plane that we're measuring on, that's the axis. Okay, so imagine a flat line. This will be below the line, this will be above the line. Then what we need to do guys is we just need to make sure that we have a value larger than minus 50. So we need to select this arrow. So larger, if x is larger than minus 50, not smaller because we'll be going to bigger minus numbers. Think of your number line. And then we need this one to say smaller than 50. This one's right. Okay, so if x is between these two values, it's going to show a straight line. Now the smaller these numbers, the finer tuned your spirit level is going to be. And if you are interested, 10 degrees is equal to 173 milli-Gs, which are what these are measured in. Okay, so that's how to construct the mid block. Now if you get that far, this block will be fine enough to show your spirit level working, and this block of code here will work on its own. Okay, so if you want to pause the video now to look at that block of code, then you can. And what I'll do is I'll zoom in slightly for you so that you may see what's going on. So you can pause now. Okay, so what I'm going to do now is I'm going to delete that block of code and then talk you through my main code and how it works. So at the far end, or if we start, we'll start at the far end. So you can see that if this value is greater than 300, then it's going to show an arrow that it's way off. Okay, if it's between 50 and 200, now bearing in mind I've got an equals to here because I want it to be equal to a 200, but just less than 50. Okay, now it's going to show a slightly less off-center line. And there again, you're familiar with this one. This is the level. And if we go the other way, it will be less than -50, but more than -200. Okay, that will work there. And then if it's less than -200, it'll show an arrow way off. Okay, so what I'm going to do, guys, is very quickly start at the top. You can see the blocks I've used, and I'm going to slowly scroll down so you can see the code I've used. Okay, so we'll do it this way. And you can pause the video at any point here to see what I've done. Okay, so just a quick in-program test. If I go over to my program, you will see that the number of milli-Gs it is experiencing is listed here. Now, it goes to 1023, but I know for a fact that it will only be able to go 1000 degrees in real life before it starts giving you issues. That's because 1000 milli-G is worth 1 G, and that is equal to 90 degrees. And if you're at 90 degrees, then you're actually on the vertical axis instead. So you'll see this working. As soon as we get to about 200, it's going to give me a smaller arrow. There we go. And if we go below 50, it's going to give us flat value. There we go. It jumped. It's very sensitive. Above 50, another arrow the other way. And below 200 then, so below -200, there we go. So you can fine tune it by making the number smaller, and if you want to, fiddle about and have it show different things on the screen, you can design yours the way you please. And all I want you to do, guys, is just submit maybe a screenshot of your code. Now bearing in mind, it's unlike Scratch because what you have is one box, so you can show me your code in whole, and then maybe you can show me a video of it working. So that's all I need a screen cap of, really, guys. One screen cap will do. Okay, now as an extension, if you are interested, I will provide a table of what each 10-degree increment is worth in milli-Gs, and if you wanted to create a protractor using the microbit, you are more than welcome. But it's not something I will be covering in lesson. However, I will show you one on the microbit working sometime soon.
So, in case you were wondering, here is the code on a microbit. So remember, it's not set to run under a button, so as soon as I turn it on, we'll get the animation straight away. There we go. So that now proves that whatever surface I've got it on currently is level. So what happens is, we put it flat, so you can still see the animation, and if we tilt it to the side, you'll notice that we're not central anymore. If we tilt it to the other side, there we go. Okay, so it works really, really well. It also works flat this way. There's one way. There's the other way. And guys, what it doesn't tell you is that if you violently push it one way or the other, it will actually work because it's measuring G's in whatever plane you are pushing it. I hope you enjoyed programming that one today, guys. What it does show you is that code can be used in practical applications and why it's important in the real world. See you next lesson, guys. Bye.